Hey everybody, this is Mike from ProofSweep, and in this new video series, and specifically in this video, we're going to talk about DeFi, decentralized finance on top of Ethereum, and how we can algorithmically trade between different cryptocurrencies that might be pegged to stable coins or traditional Forex assets or stocks or whatever, as well as use leverage, take a certain side of the trade, long or short, as well as just doing run-of-the-mill trades. In this first, so that's the series. In this first video, we'll just talk about how to set up our Solidity environment and get our Solidity code in place to actually execute trades from different platforms, as well as our Node.js application, which can actually monitor the Ethereum blockchain, interface with our smart contract and tell it when to execute a trade. Now, the cool thing about decentralized finance is that because it's your Solidity contract that's running on the Ethereum blockchain that's executing a trade, when you check for pricing data, that pricing data is the pricing data that you are going to get at execution. So for example, if you see something happening on your Node application, you say, hey, smart contract, run this arbitrage or run this particular trade. Unlike like BitMEX or other centralized exchanges like Binance, where that trade might go away when you execute it, you can actually check at the moment of execution if the price is still the same on in both venues that you want to trade across. Also, for example, you could trade across multiple venues within like in the same microseconds. So as opposed to having to like buy something on BitMEX or Binance, wait for them to approve your withdrawal and then get the funds from there, you can all execute that instantly, right? So we're going to talk about that. There's really cool stuff coming down the pipeline with like Aave and other players like that actually will offer you flash loans or liquidity so that you don't actually have to have any money. You can use their money. They take a small percentage. You can get your trade through, return the money in the same transaction. So it's riskless to you, but that's not available quite yet, but it will be soon. And as we go through the series, hopefully we'll be able to offer tutorials on how to do that, etc. So without further ado, let's get started setting up our Solidity smart contract as well that runs on Ethereum, as well as our Node.js application that can monitor the Ethereum blockchain and call our smart contract to execute the trade. So here we go. We'll start with this repository called OrFeed smart contracts. And in the end, we're going to make a transaction that's going to mimic this one, in which we're going to send over some Ether into the smart contract, and then it's going to use decentralized marketplaces to purchase DAI stablecoin, which is just a Ethereum token that's tied to the value of the dollar. So we're going to execute that trade by deploying a smart contract that looks like this, that actually executes that. So really we're going to look at this logic here to buy DAI, call the smart contract for DAI, initiate an exchange, send over some money to that exchange, and in one synchronous way get the funds and then send that back to the user who sent us the money. And the cool thing about this is that we can then later take the same token and trade it on another exchange right after. So we can buy it on one exchange cheaper and then right after sell it on another exchange more expensive. And we can then automate the finding of this and the execution of this using our Node application, which looks like this. So this is our application that's actually going to call our smart contract, and we'll also talk about how to put that on the cloud. So there's going to be a lot of covered in this video. Hopefully we're going to get this in really quickly, but one of the key pieces to remember is this video is going to move a little fast, and we're going to cover a lot of ground, but it's going to be all the pieces that you need to get started with your smart contract development, as well as your DeFi usage in regards to plugging into other platforms, pulling data, as well as getting libraries. So this video is meant to be watched over and over again, because I don't imagine that most people, if you're brand new to programming or if you're brand new to DeFi, this is going to be something that you're going to watch once and then say, and you could be a genius, in which case, great. But just FYI, this is going to move really fast. We're going to actually just do all of this really quickly. So let's start with the smart contract. the first thing we're going to do now, I'm using a platform called Atom, which you can download a Solidity viewer. So Solidity is the programming language that Ethereum uses, and that's the programming language that you'll need to understand in order to write smart contracts. There's also Viper, but most programmers code in Solidity, so we're going to be using that. And what I'm going to do here, we're looking at a Solidity smart contract. I'm going to take pieces of this, for example, this chunk, and I'm going to make it, I'm going to collapse it, or rather fold it. I'm going to fold this one as well, because these are just libraries that we're using that actually get the entire application to work. So none of this is our code. This is just an interface that allows us to, for example, interface with the Uniswap exchange, ERC20 tokens, and the OrFeed Oracle for pricing data. All right. So we're using those. We'll talk about those more down the road. The main thing that we're doing here, our smart contract that invokes the above libraries, is just this little piece of code. It's about 25 or so lines, right? 28, 29 lines of code. Okay. And so we're going to focus on this, and a lot of that's just commented out. There's very little. So we're going to go over what this does. So it's a contract, has a name. This is arbitrary. You can name your contract anything. This is called the Uniswap trade example. And then what we do then is we create a function. Now, a function is just something that does something. And this one's called by die. What we'll talk about also is how you can get this code. I'm going to swing over here to my terminal. So if you have a Mac, you'll be on the terminal. If you have a PC, you'll be using the equivalent of a Mac terminal where you can just enter commands directly in. But this will be mostly for Mac/Ubuntu users. You can still follow along if you're kind of familiar with coding and stuff like that. The first thing you're going to want to do to get started is switch into a directory. I usually go into my apps directory where I do everything. And you're going to do a git. Now, if you don't have git and you're going to be working with this stuff, you'll need to download that. But you're going to write git clone. This allows me, and I'm going to paste in the URL for OrFeed smart contracts. Okay? So I'm going to push enter, and it's going to create a directory called OrFeed smart contracts. So I can switch it to that directory by saying cd OrFeed smart contracts. And now I'm in that directory. I can now click open, and this is where I am now. So we have our smart contracts, and then we have examples. Examples is where we're going to put in the future more node examples for doing things. The first one is just our basic node example. So we're going to be looking at that. Now, if you're not familiar with Node.js, it's a backend programming language. It's separate from Solidity, of course, and it is the piece that is going to call your smart contract whenever. So your Node application kind of sees what's happening in the world, can look anywhere, can Google stuff, can find out the weather. I don't know. It can do a lot of really complex things with information out around the world, and then it can take that information. It can also read from other smart contracts on the blockchain, on the Ethereum blockchain, on the Bitcoin block, wherever, and then it can then call our smart contract. So we need something to call it. Now, manually, we could always go through with MetaMask or whatever. And if you're not familiar with MetaMask, I highly suggest that you pause this video, go learn a bit about it. But MetaMask is simply an extension that allows you to kind of, manage your accounts and interface with dApps or decentralized apps, applications. So, for example, one that we created a few weeks ago is called Structured F. It allows you to go on a website like this, click on a button, create a package of multiple. This is a good example of DeFi. 0.02 F. I'd like to convert it, and then it creates a pop-up for you that allows you to just kind of log in and finalize that particular thing. So I can confirm this, for example, and then what I'll be left with, is a leveraged position in Ethereum and Bitcoin, as well as 80% of a portfolio in a loaned out asset that's going to earn me interest. So I have a hedged portfolio that just generated. So that's what dApps are. If you're not familiar with dApps, they allow you to do weird things like that without needing a bank account or anything like that. And you could just use your MetaMask wallet and do all that kind of stuff. But if you're not familiar with that, I highly suggest pausing this video, go and check that out. All right, so now let's go over and I'm going to look at that clone that I just created. So I said that there's an examples folder. What you're going to want to do with this examples folder is copy it and then take it, and then I'm just going to paste that in over here. Examples. I'm going to rename it to something else. I'm going to call this my Node Trade Bot. Okay. So this is like a separate application altogether, but we included inside the OrFeed smart contracts to help get people started. So as we continue doing these classes, you'll see more and more different examples in here that you can pull out and then create their own kind of application. So let me just get everyone started with how that works right after we go through this Solidity smart contract. So that node application is going to just do simple reading and writing. So this is what the node application looks like. We'll talk about this in a second. But basically, it can take a wallet. It can take a private key, right? A private key just is the password to a wallet that might have money on it. So I might have money on this address. And this private key authenticates and allows me to control the funds that are there on this address. And then a smart contract address or a token address or whatever, we're going to interface with this contract. We're going to load in some data about it. We'll talk about what an ABI is when we deploy our smart contract. And then we're going to load the smart contract up, and then we're going to call methods. So, for example, we can get the price of DAI, or rather, we can get the price of Ethereum to DAI. And then additionally, we can buy DAI. So we can actually go directly from our node centralized application, interface with the smart contract, tell it when to buy DAI, right? So we can have a timer that just buys it every hour. We can have something that looks for certain conditions in the world, like there's a tsunami in somewhere, and now we want to buy DAI. Whatever we want to do, then we can interface with that smart contract. And the smart contract could be endless. It could buy DAI, it could do arbitrage, it could go to, like for example, structured, create a portfolio, whatever. And then after that, we'll talk about little functions. Like for example, we're not really going to get into that deep into this, but we'll talk about kind of just calling the methods. And this is a really dumb application, meaning it does one thing really simply. It literally just gets data from the smart contract that we're about to deploy, and then it makes a trade. It calls the smart contract, and the smart contract makes a trade. So let's talk about the smart contract. The smart contract's here, and essentially we have address, DAI address. So in Solidity, we have data types. Address is a data type, and if you're not familiar with data types, that just means a type of thing. So there's usually integers, uint 256, so integers like number. String is words. Var is a collection of variables, a collection of addresses, or a collection of integers. In Solidity, usually they're called arrays in other programming languages. So we say, okay, we have an address, we give it a name, and then we paste in the address. So this is the address. If I copy this and I go to etherscan.io/address, and I paste in that address, I'll see that it is the, this is not the DAI stablecoin address. This is the DAI Uniswap market address. So if you look at this smart contract, this smart contract actually allows people to do token purchases, add liquidity. It's for this website, Uniswap.exchange, where you can easily go in, and this is another dApp, and you could select any token. I have F. I want to convert it to AMPL or into, let's find a cool one. There we go. Kyber network tokens, right? So I have this thing. I want to convert it to that thing. And in an easily decentralized fashion without any middleman, I can do that. So I could do it here, and I'm in interface with their smart contract, or my smart contract can do it. But the thing is, my smart contract could do a lot of things with this exchange, with other exchanges, all in one foul swoop. So over here, I'm calling this marketplace, which is just the DAI marketplace, and then I'm creating the object. So up here, I introduce the Uniswap exchange interface. I'm just calling that interface, and we call this creating an instance of it called USI, and then I'm setting a parameter of the DAI address. So that just basically what this does is just creates the exchange. This one line of code, I've created an entire exchange. Isn't that amazing? And then I say the amount of F I want to use, and so msg.value, message.value is in any smart contract, the amount of ether that's been sent to the smart contract. And in order to send ether to a smart contract, you have to specify that it is payable. So if a function has the word payable in it, it means that it can be sent money and manage money and do stuff with that money. And then here, I just get the DAI token. Now, this was the address I was mentioning earlier. This is the actual DAI token. So if I take this address and I paste it up here, etherscan.io/address/this, I actually can see all of the DAI transactions. So we can see that maybe 1 to 2 a minute transactions happen with DAI, right? Which is actually not that much, but it's quite a bit. And I can actually see the contract. So this is what makes the DAI stablecoin work. This is the Solidity code. And because you're learning Solidity, it's just what you're learning here, but a lot more functions. And, just methods and things being called. So you'll be able to understand that pretty quickly, pretty soon. And if you don't already. And then, so what I do here is I create an instance of the DAI token called DAI token using ERC20 library, which I have up here. And then I do a DAI token dot, I use that object, I call a method called transfer. And then I transfer it to another keyword, msg.sender, which is the person who sent the money. So msg.value is how much money was sent. This is an address type of who sent the message or the money. And I'm going to transfer to them the amount I got back. Okay, so I did the transfer. And up here is actually the whole transfer. I sent over the amount. I called the exchange object. I said F to token swap input, which is just a function. I sent over the amount, and I said do it on this block now. And then transfer whatever I get back in DAI token to the person. So you send in F, I will exchange it and give you back DAI. And in the future, like we said, we might do a bunch of stuff. We might go to Kyber, take that DAI, convert it to C DAI, earn some interest, then send it back. I don't know, do anything. And then I return how much I got back. Then over here, we do a thing. We have a function that's constant, which means that this doesn't cost anything to get the information. So this is free data that anyone can access. Whereas this, you have to actually pay something. And you have to also pay gas, which is just how the Ethereum blockchain, what the Ethereum blockchain itself charges you to run a transaction. So there's free transactions, and then there's transactions that cost you money. Things that don't have constant in them are things that are going to cost you money. And constants are just things that return information. So for example, this one uses our OrFeed library, which is a platform that we created that soon you can use to get all of the arbitrage opportunities. So you can use OrFeed to say, what's the price on this exchange? What's the price on this exchange? What's the price on this exchange? And then you can use a function like this to then interface with those exchanges using the Oracle data to then create arbitrage opportunities and whatever, and advance your learning into how smart contracts work. So in this case, I'm creating an OrFeed instance, calling the OrFeed Alpha smart contract. And then I'm saying, hey, get the exchange rate for F to USD. And I put the amount that I want to get. And the reason I use this large amount is because of the way decimals work. And so one interesting part about Solidity is that, which is the Ethereum smart, which is what we're looking at here, is that there are no decimals. So for example, a number, if it had 3 decimals, if this number had 3 decimals, or if this number had 5 decimals, it would be 1, 2, 3, 4, 5, and there'd be a period here, and it would be 1,000. So this number with 5 decimals is 1,000. This number with 6 decimals is 100. And so you gotta kind of have to learn to read numbers like that, like know how many decimals are in a number. There's a long, complicated story, but you could type in like decimal Solidity and learn like why Solidity doesn't have decimals. And essentially, decimals are just a figment of our imagination in the first place, because every number is just a number, and where we put the dot is kind of just in our minds, and we keep up with it. So Solidity kind of recognizes that and works with that. So, and then this little one here, and you could put in who you want to get the data from. So Kyber, buy, Uniswap, sell, whoever I want to get the data from, I put in here. So this is just like the average price across many. So I can say, okay, get the exchange rate. So this will just, and it will return me the price. So this one's just so we can learn how to use and read functions. And I could, in a future thing, I might read from 20 or 50 different feeds. I might get the exchange rate on Ethereum, USD on a zillion different platforms, or BTC or USDC on a zillion different platforms, and then use that to trigger when to buy and sell things. So we'll show how to call these functions. Now, if you go to the smart contract up here, which we've left an address, so you can always go and see like, what's going on with the smart contract by going up here. And this original contract will always appear here because it's been verified. So here I can see the contract. And let me close all these tabs out because so I can go here and click on contract for this contract and look at the contract code. And Etherscan has verified that the bytecode, which is just the code that's generated when I deploy the contract, matches this. And so whenever you're dealing with smart contract, it's good to make sure that it's been actually confirmed by Etherscan, has the contract source verified exact match, because that means that the person who created the smart contract is being transparent with you about what's in it. And these rules can never change, which is really fascinating. But they can be updated if they're written to be updated. That's important also to always remember. All right, so that's a quick introduction to how that works. So let's actually get some of this to work, right? So yesterday we did one simple transaction over here, and you can see the transactions that we did by clicking on transactions. You can see that we sent to this contract, and you can do that too by testing. You won't lose any money. You'll send Ether to it. It'll convert it to DAI, which is just USD. And then you could take that to Uniswap or wherever and convert it back to ETH if you want. So you can always use this smart contract to see exactly how this code works and to understand it. And additionally, you can interface with it directly by, for example, we have this here, this address. You can switch out the word address for DApp. And I'll do that. Instead of address, I'm going to type in DApp. DApp. So what this let me do is read the contract. So all the constant functions, I can see here, get DAI price 183.20842883. So that's the exact value right now of Ethereum. And then I can do a write to the contract and then do buy DAI. And then I can set how much Ether I want to send. So 0.01 Ether, click write. It'll say connect to Web3. It'll probably give you a notification to do something over here on your MetaMask or whatever, if you're using Formatic or if you're using Portis or Tau or one of the newer different kind of things. I'll click write. And then this will send funds over to it. I'm going to make a high gas fee so it gets through the blockchain quickly. So the higher I pay in gas, the quicker it'll get confirmed. So I just sent that money over. And so you can interface with your smart contract the same way, but you'll need to verify the smart contract. So let's just do that real quick. Let's talk about how to spin up your own, because I know you're going to want to do that. So you just copy the code. You take it over to a place like remix. Ethereum.org. So you can go to a website like this. Now, this is the new layout. In which case you can just click on, anywhere like this, and you can just paste in the code that you got over here, and then you can then take that and deploy it, right? So this is the UI that most people use. I'm going to use the old UI because I'm an old school kind of guy. I like the older version more, but use that other version that you just saw. Do it just like that. And I'm just going to paste in the data. And you'll select a compiler. So we're using version point. We're using 0.426. Okay. So I'll select the compiler version. It'll give me a bunch of warnings saying, whatever, but it'll say that as long as you don't have any red in here, you can deploy that contract. I'll go over, I'll select run, and then I'm going to click the Uniswap trade example contract, and then click deploy. All right, and as long as I have MetaMask enabled, I'll set my gas to 4 because I want this to go through quickly. And then it'll ask me, okay, pay 23 cents to deploy the smart contract. Yes, sure. Confirm. And that's it. I can look here and then open that up. And there's a zillion ways to deploy smart contracts, so you can look up your own ways. That's my way. You can go to Remix, as I showed you earlier. The new version is how a lot of people do it. You can use the older version of Remix, or you can do it. Some people have actually gotten Atom to work directly, deploying smart contracts from here. But that's new tech and can be buggy. So FYI on that. But yeah, Atom can do it potentially. And so eventually this will confirm. And for other people, what I want to do is I want to take that smart contract code that I just wrote, and I want other people to be able to verify that it's true and then interact with it myself and test. And you should definitely do that to make sure, at least in the beginning, is while you're learning. So as soon as I get a confirmation here, which I should very soon because I paid 4 Gwei, and I can actually look at the gas station Ethereum to see what the average prices are. This will all be gone eventually because things are changing and Ethereum is updating, and so gas is going to be much different than it is today. But for now, that's how it looks. So if you're looking at this in 2021, you're probably like, what? But this is how we were doing in 2019. And so now I've verified the contract. So that contract 39 seconds ago was created. I can click on the contract, click on contract again, click verify and publish. And then I put Solidity single file because I did a single file. Now, a lot of people sometimes what they do with their Solidity contracts is that they break all their stuff into many different files. So for example, you don't need to just have everything, all your interfaces in one file. I do this way as an example to show people, like, just put everything up front. That's why I even collapsed it, which is almost like keeping it in a separate file. And so, however you want to do it, but this was a single file. I'll put, and I just want to know how it was created. I'll put the version that I used, the license. This is like, I'm publishing it, like, can other people use it? And then paste in the code data. And I just click, I'm not a robot, and verify and publish. And then their bot right now checks that all that data is correct. And they say, okay, that's correct. And so I can click on that smart contract. And now I can just send money directly into here. So I can go to the address and take out the word address in the URL and put in DApp. And then I can read the contract, get the price. Oh, look, the price has changed very slightly, right? I can write and do the same thing I just showed you. So there you go. Now you've deployed a smart contract. It's in the cloud, or it's in the Ethereum cloud. It's in the Ethereum runtime environment, whatever, global state machine. And now I want my app to be able to interface with it. Or I have someone else wrote a smart contract like this one, and I want to interface with that smart contract. I want to do something with it, like automatically, determine when it gets called, when it buys something, when it sells something, when it does a special function, right? So as we mentioned before, in the OrFeed GitHub, there's a few things. There's the contracts and there's examples. And so what we did was we created a new folder, as you recall, over here called the Node Trade Bot. We renamed it, right? and we have our node basic example in here. So I'm going to do a few things. One thing, I'm going to show you how to actually get this thing running and run it. And then secondly, what we're going to do to have it execute a trade, secondly, what we're going to do is we're actually going to deploy it to the cloud. And this doesn't require much knowledge for you, but you'll actually have a website where you can actually call this function and actually have it execute anytime. And we're going to use Heroku for that. So Heroku is a great platform for just quickly spinning up environments without having to worry about all the security stuff. They take care of all that stuff for you and things like that. So one thing you'll need is the Heroku command line tool. So you can go to Heroku.com and you can download that or whatever. But let's go ahead and talk about the code first. So in here we have a Node.js application, and I'll talk about the basic of what it does. So index.js is usually your Node.js main file, right? And if you look at this directory inside of here, you'll notice there's an app.json file, a package.json file, a proc file, a README file, views, public. Views and public are all just like Heroku templated. They just get, and then proc file and app.json. This just gets Heroku up and running as far as deploying your application. So you don't have to touch these. The only thing that you're going to have to touch is your index.js. And so here's what I'm going to do. I'm going to take this and you drag this over into your terminal. Okay. So I'll create a new terminal window that's in there. And the first thing you're going to do is you're going to type in npm, and make this bigger, npm. And you're going to need, if you don't have npm and it doesn't work, type in npm and nothing happens, says something command not found, get it. But you'll say npm install. And then what it'll do is it'll actually install everything that's inside of your package.json file. So in here, you're saying, hey, I need Express, which just serves a web server. I need Cores, which is, we'll talk about that later. It's like cross-site stuff. SHA-3, which is just a hashing library for cryptography. And this is cryptocurrency, so you need that. And if you're a Web3 provider, we're not actually using this, but you might use it in the future. So I just went ahead and put that in there for you. Web3, which is, we're in Web 2.0 right now. We're going to Web 3. This is what Ethereum's all about. So this is what actually you're using the most of to actually interface with your smart contracts from your server to the smart contracts, all Web 3, the Web 3 provider engine. And then play sound. And the reason we do that is because later we might actually make it like make ding, ding, ding sounds, whatever, when there's an arbitrage opportunity or something like that. It's really fun to do. That's for later. So some of the stuff's for later. And it just kind of tells it how to set up itself. And so now I'll see that everything, all the packages have been added. Okay. So added 595 packages. And then all I have to do is type in npm start. And by running this simple command, simple but powerful command, it'll start my app. So it'll say starting. It'll listen on port 5000. And then if I go over to port 5000, now let's look at the code real quick so we can see what's going to happen. So in index.js, if you're new to coding, look at this. I say app.get. Now, in the future, we're going to do a bunch of other cool stuff. And I commented this out just because it can be used for later for like the advantageous people out there who want to like jump ahead and like play with stuff. I put some stuff in here. I commented some stuff out that you could probably kind of play with and turn on at the moment and use. But all the stuff that's not commented out, and when I say commented out, I mean just it's not used, but it's written. It will be either used later or something that you can kind of play with on your own. But all it's going to do is going to do a rest.send, means it's going to send a response to the web page of example response. So if I go to localhost 5000 example response. So that's on my local computer. I'm running a server that says example response. Okay. Now you could have a whole website inside there or a file, which is why we have a thing called public and views or we actually put HTML or whatever if you want to serve it up. But that's not what we're doing today. Then I have example transaction. And what that'll do is it'll call a function called example transactions, which is this one. And this one has my private key, has no money on it, so you can steal this all you want. The address, my smart contract address, the one we just deployed. Same one as we just deployed. This is the one from yesterday. Same exact thing. It authenticates me with my private key into the wallet. And then it allows me, and then I just upload information about the contract. So what's the ABI? The ABI is an interface for your smart contract. In order to interface with it, you need this. And we showed how to deploy a smart contract earlier, but you can get that simply by just, when you deploy a smart contract on any platform, you could just go over to compile and copy ABI. If I click on OrFeed trade example, ABI, and then if I paste that in, it'll be the same thing that you see here. So new file, paste, yep, this and that are the same. Okay, great. Don't save. Okay, so that's what ABI is, so it helps me. So then I say new web3.f.contract, and I say, here's the ABI, here's the smart contract. And this initiates, this one little line of code, initiates the smart contract and allows me to work with it. So now I can call methods on it. So I can say method.getDiePrice. .call is for constant functions, where you're just gonna get some data back. And send is for non-constant functions, where you're actually going to pay some money, or you need to pay gas on the blockchain, okay? And that's it. So all this is gonna do is gonna print out on the console, which is just this little thing over here, the price of DAI, which will be the same as this little number over here, 183, whatever. If I refresh the page, it'll probably be different. Yep, it is, 18334, whatever. It's gonna print that current value out from the Oracle. So that'll show me that'll show us how to read from our smart contract. And then it's going to also, right after doing that, it's going to buy DAI, sending 100 Wei, which is like 0.00000001 Ethereum, like a really small amount of Ethereum. 1 Ethereum would be like 0000. It's like 18 of this zeros. And that's, remember, because Ethereum doesn't have decimals. So technically Ethereum has 18 decimals because 1 Ethereum is, 18th power, blah, 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 blah. So contract.methods. So we're just gonna do two things. So let's try it. So I'm gonna say / example transaction. Check your console, and in my console, first thing I'll see. Now you'll get this error because there's no money in there. The first thing you'll get is the DAI price, and it'll say, let's check this, 183.3496, blah, 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 blah. And I'll go back to the smart contract, and I'll read the contract. Let's see. Yep, 990. Yeah, cool. So that just read the smart contract. And then it says insufficient funds. You don't have money, dude. Like, whatever. And I don't. So let's just go ahead, and I'm going to send a little money into it because that's how we can prove that this whole thing works, right? So I'm going to go over here. I'm going to take this smart contract, or I'm going to take my address. I'm going to send some money to it. That means that like other people who play with this can probably just steal some money. It'd be great. So by the time you're watching this, whoever you are, someone else is probably taking this money. They wouldn't have been nice and just said, oh, I'll just keep a little money here so other people can test with it, play with it. No, that's not usually what happens. So let's put 0.02. That's all of, almost $4. There we go. We're giving that to the universe. We're giving that to people out there. We'll see what they do with it. This is actually a great experiment in human nature. So, fun, interesting fact. Part of this video was cut out, and the reason was because this original private key that we used, as soon as it's published to GitHub, a transaction is created and the funds exit immediately. So someone has some kind of weird bot probably on GitHub that is taking, so you don't put a private key on GitHub, that's obvious, but it's really funny because all we did was just not push it up to GitHub, and then we got a different result. So That's funny. That's just really funny. Anyways, now it's working. So the application that you're going to use, you're going to have to load up your money. Don't push it to GitHub with your private key, and you should be fine. So eventually this transaction will go through. We used a really low gas price. All right, so there you go. That's a simple way to get the application running. And now let's talk about how to deploy this actually to Heroku. So I'm going to close this application. What I'm going to do is you're going to need the Heroku app. So you type in Heroku, log in. And if that doesn't work, then you'll need to download Heroku. And then it will ask you to authenticate. So it'll open up Heroku for you. And it'll say, hey, log in. And once you log in, so after you do Heroku login, then you'll just do Heroku create, and you'll give your app a name. So I'm going to call this app Node Trade Bot Solidity. And that's it. It will then create the application. And then you just say Heroku git add not a repository. So in this case, what you'll need to do is to say git init to create the Git repository, so you can push this code up. If you're not familiar with git init, then just look it up. You'll learn what it does. So I'll do git add. This adds all my changes that I made. Git commit. This adds a note, added stuff, to my commit, so I can always get back to this place. And then you'll do a git push Heroku master. There's no Heroku, and in that case, you just copy this URL here that they gave you when you created it, and you say git remote add Heroku. You give it a name. I call mine Heroku because it's on Heroku. And then I paste that in, and then git push Heroku master. And that magic ingredient will actually then deploy this to the free application that you just generated. Now the problem with free applications is that it'll shut off every few hours. But if you pay and you upgrade it to $7 a month, then it'll run continuously. So this server will actually run. It's a free server, so it'll shut down. So that kind of sucks for Node apps, because usually you're doing something 24/7 that you want your node to constantly be monitoring stuff. But just to kind of get you started on like how do you actually deploy this thing, I'll be able to actually go to this URL and do the same thing that I previously did. So I'm going to pull the window down. So then you'll see it in your list, and then you can just click Open App. And what you'll see is simply the example response that you saw previously. So there it is. And then I can go to / and then I can call my function. So I can call the example transaction function, and it'll actually perform the transaction. So it'll say, hey, look at your console. And in order to do that, all you have to do is just type in Heroku logs in 50, see the last 50 logs. And this is how you can see your Heroku logs, just like you did on your local computer. So there you go. There's my transaction hash. There's the price of DAI, right? So there we go. We've deployed something. It was awesome. It was really great. I just created another transaction. My previous one went through. I sent money over, and it converted it, the very small amount. I transferred 0.00000001. And remember, in the smart contract code, we saw here that the example only sent, and this actually needs to be a really small amount. So a very small amount of, and I'll just, for the example, make this a little bigger for you guys in the future. So there we go. We just deployed a server that can read smart contracts, can write to smart contracts, as well as deploy a smart contract and facilitated a DeFi trade. So there's an intro. Like I said, this is probably a video that you'll maybe go back and watch a few times, depending on what your familiarity is. But in the next few videos, we'll go over more complex things that we can do to build on top of this to actually perform some arb or do instant margin trading or other different things that we could do that's unique and interesting in the DeFi space. So stay tuned for that, and thank you very much for joining us.